In this video, I want to explain about the machine learning classifier that I worked on. And so this is the data set that I choose. This data set I get from kaggle.com with the title is Alpha Thalassemia Dataset Carriers versus Normal. So basically this data collected from alpha thalassemia carrier children and their family members screened from 2016 to 2020. There are 16 independent variables in these data sets, consist of some parameters related to blood, and the target variable is the phenotype, whether the result is alpha carrier or a normal person. So the purpose of this data sets is to differentiate thalassemia carrier states based on full blood count and hemoglobin variants to differentiate between normal individuals and alpha thalassemia carriers. I am motivated to choose this dataset because I am interested in hematologic diseases, especially thalassemia. This concern came since one of my family members has this disease. This disease can be prevented by holding back the marriage between thalassemia carriers, and I found it essential to know the characteristic of the thalassemia carriers to prevent this disease. So the first thing that I did for this classifier is to import the library used in this classifier. Then I also import the dataset from alphanorm.csv into the Google Colab. Then, as we can see in this data, the sex features is using string data type, so we have to transform it into the integer form using dot replace. So we transform the female string into 0 integer and the male string into 1 integer. After that, we have to exploring the data. We have to use data shape to know the rows and the columns. So there are 203 rows and 16 columns in this data. This is some of the columns using data.columns. Then we can know the information of the data using data.info. From this information, we can know that RBC and MCH has null value since the RBC is only have 202 non-null value and the MCH only have 201 non-null value. So RBC has 1 null value and the MCH has 2 null values. So we have to fill the null value. In this case, I use the average value of each features. We're using the fill-na and transform to fill the null value with their average values. So we have to recheck again with data information whether the null value is filled. So from this information, we can know that the RBC has 203 non-null value, and also the MCH now also to have 203 non-null value. So after that, we can see the data, the correlation between each data using SNS.heatmap. So from this figure, we can see that the lighter the color, the more the correlation between data is higher, and the darker the color, the correlation between the data is lower. We can also using data.hist to show the histogram of each data. From this picture, we can see the distribution of the data, the amount of each value for each features. We can also see the outliers that the feature have. For example, in the RBC data, there are some outliers here in between 0 until 3, because most of the data is between 4 until 7 approximately, but there are some outliers here. We can also see in the PLT data that there are some outliers here in the 1000, because the average data of PLT is between 0 until 750. Besides using histogram, we can also see the outliers using box plot. For example, the PLT data, we can see that there is outliers here. It's the same as the RBC. The RBC data, we can see that there are some outliers here under the 3. It's the same as the result shown in histogram. The next step is to splitting the data. So for data splitting, I split the data into 2 subsets, the test data and the trained data. First, I differentiate the X and Y, where X is the target value or the phenotype. It's the last column in this data, and the Y is all the parameters it took from column 1 until column 15 of the data. After that, each subset then divided into 2 parts, the test data and the trained data. So there are 4 variables: X train, X test, Y train, and Y test. The amount of the test and training data can be divided using train test split library from sklearn model selection. In this model, I use 0.30 for test size. It means I use 30% of the data to be tested, and 70% of the data will be the training data. And the random state is 0, meaning that every training that I do in this data training, the result will be the same. And after that, I also using decision tree classifier using entropy criterion. So here is the result of the tree, the decision tree. From this experiment, we can see the result from confusion matrix, classification performance, and accuracy score. Confusion matrix used to illustrate classifier performance based on the true positive, false positive, true negative, and false negative values. Figure below shows the confusion matrix of the classifier. We use 30% of the data for testing. Therefore, there are 61 data being tested. From those data, 36 data are true positive, and 5 data are true negative, 10 data are false positive, and 10 data are false negative. This model has 36 positive cases correctly predicted and 5 negative cases correctly predicted, while 10 positive cases and 10 negative cases are misclassified. The classification performance consists of accuracy value, precision value, recall, and F1 score. So the precision is a measure how many of the positive prediction made are correct, and the recall number is a measure of how many of the positive cases the classifier correctly predicted, and the F1 score is a measure combining both precision and recall. And from the accuracy score here, we got 0.67 and so on. The accuracy describes the number of correct prediction over all predictions. So for the conclusion, this data shows how some variables of the blood leads to the characteristic of people with alpha carrier of thalassemia disease. From this experiment, I can conclude that the classifier model works well in this dataset, but it needs some tuning to make the predicting better. I believe this machine learning will help people in the laboratory to check if a person is a carrier or not. So this will prevent newborn with major thalassemia in the future. I think that is all for my explanation. Thank you.